video by Cameron 5. Now, after having studied the Gibbs free energy, the theoretical part of this chapter is almost done. Not almost, like entirely done. And now we're going to be doing some past paper practice to solidify understanding. So the spontaneity, feasibility of a chemical reaction depends on the standard Gibbs free energy change. This is related to the standard enthalpy and entropy changes by the equation shown. State and explain whether the following processes will lead to an increase or decrease in entropy. The reaction of magnesium with hydrochloric acid. So when magnesium goes into hydrochloric acid, it produces magnesium chloride and a mole of hydrogen gas. We have always studied that when gases are produced, more and more entropy is produced because matter is dissipated in the form of gas. So it is positive entropy change, and the reason is that hydrogen gas is produced. Hydrogen gas is produced. Solid potassium chloride dissolves in water. So when a solid dissolves in water, what actually happens is that the crystal lattice is dissolving, and now the particles can dissolve and dissipate and spread more in the water. So that is again a positive entropy change. The reason is that KCl has now freely moving ions which are going into water. So the lattice is dissolving into freely moving ions. The word freely moving ion itself implies more and more randomness. Steam condensing to water. So now steam was a gas, and now when it's coming into liquid state, there is basically less entropy. So there is a negative entropy change because a gas is basically converted into liquid. So gas is converted into liquid, so less gas is available, and less gas basically means less spreading of matter. Now this question B says magnesium carbonate can be decomposed. Obviously decomposition is always an endothermic process. Standard entropies are shown in the table. You have the values. Calculate delta G. Include a relevant sign and give your answer to three significant figures. So delta G is equals to delta H minus T delta S. Remember, delta H value is in kJ, but delta S values are in J. So convert this into J value, which is 117,000 joule per mole. So it becomes delta G is equals to 117,000 minus 298 Kelvin times product entropy minus reactant entropy. The product entropy is 26.9, which is magnesium oxide, plus 214, which is carbon dioxide, minus 65.7, which is the magnesium carbonate, 298 as it is, minus as it is, 117,000 as it is. When you solve these values, let me do it on a calculator. 26.9 plus 214 minus 65.7, 175.2, and then 64.79. So it becomes 64.8. This is positive value. Yeah, they want the sign already. Yeah, so that is positive. Explain with reference to delta G why this reaction becomes more feasible at higher temperatures. Temperature controls the T delta S term. So if temperature is controlling something, you have to talk about the T delta S term. Now what's happening? At high temperature, the delta G is becoming more feasible. More feasible means more negative. Why is it happening? Why high temperature makes a value negative? That is because the delta S is positive. You can also see from the equation, now carbon dioxide is made, which is a gas. A gas includes more entropy changes, positive changes. So if delta S is positive, T delta S would be positive. And when T delta S is itself positive, what actually happens is at high temperature, T delta S becomes more bigger value, so delta G becomes negative. By more bigger value, I should say at high temperature T delta S becomes bigger negative value. You don't have to write this entirely. The keywords are delta S is positive, T delta S would be positive, delta G becomes negative. This is your keyword. The other thing is just to over explain stuff. Moving on. On heating, sodium hydrogen carbonate decomposes into sodium carbonate as shown. Calculate the minimum temperature at which this reaction becomes spontaneous. Now we know that delta G should be taken as 0. So 0 is equals to delta H minus T delta S. 0 is equals to 130 kilojoule, right? So kilojoule becomes 130,000 joules minus T, and delta S is 316. T 316 is equals to 130,000. T is equals to 130,000 divided by 316. When we solve it, the value turns out to be 411.1. So I would write 411. This is the temperature at which the T is at equilibrium. And now all of a sudden this reaction can become feasible at higher temperatures than that. So that is perfect. The solubility of group 2 sulfates decreased down the group. As a reminder, I should remind you guys that magnesium sulfate, then calcium sulfate, strontium sulfate, and then barium sulfate. The solubility decreases, which means magnesium sulfate is soluble and barium sulfate is insoluble. Why this happens, let's talk about it. The reason basically is that hydration and lattice energies both decrease. They both become, less and less exothermic. But what actually happens is that hydration value decreases more. So enthalpy for hydration and enthalpy for lattice, both these values we're talking about, both decrease and become less exothermic and become less exothermic. Why? Due to increasing ionic radius, radii, charge density, that thing. But then you say, but enthalpy for hydration decreases more steeply. The value of hydration enthalpy decreases more, which means that it decreases faster, and obviously solution enthalpy becomes more and more endothermic. Then as a result, solution enthalpy becomes more endothermic. More endothermic means that less solubility would be seen. So you have to talk about values. Entropy is a measure of the disorderness of a system. Wow, new information. So assume the entropy for water is 0 at 0 Kelvin. Sketch a graph. I've done this already, but let's do it again, right? This means minus 273 degrees Celsius. This over here is 273 Kelvin, which means 0 degrees Celsius. So when we continue this graph, this becomes like this. The entropy value will keep on gradually increasing at 0 Kelvin. Then here it increases more steeply and then becomes continuously increasing. What's happening here? It's a change of state. Please place one tick in each row of the following to show the sign of the entropy change. When the solid dissolves in water, it's more entropy because free ions, or I can say free particles. It's not necessarily ionic. Water boiling to steam, more gas is produced, so basically positive entropy change. The equation for the reaction that produces methanol is shown. Use relevant bond energies from data booklet. So what you'll do is you'll do the BB minus BM, bond breaking minus bond making is equals to change in enthalpy. I'm not solving it entirely over here. At 298 Kelvin, both products of this reaction are liquid. Calculate the standard entropy change. So standard entropy change is equals to entropy of product minus entropy of reactant. So what we can do is we can put the value of product, which is 70, and 127 minus the value for hydrogen, which is 131 times 3 because it's 3 moles, and 214, which is 1 mole. When we solve it on a calculator, I'm pretty sure we are going to get T plus 127 minus 131 times 3 minus 214. 410 with a negative sign. So this is the value for entropy change. Calculate the standard Gibbs free energy. So the value is going to be delta H minus T delta S is equals to Gibbs free energy. I haven't solved this value, but you can solve it. You can find it from here by using the bond breaking formula and making formula. Predict the effect of increasing the temperature. Temperature always affects the delta T delta S term. So let's go back to the question and let's see. Entropy was negative. If the entropy change is negative, it means delta S is negative. So T delta S is negative. If this part is clear to us, we should understand that if T delta S is negative, and because of the minus in the equation, there's a minus in the equation, this value becomes more and more positive. So minus T delta S becomes positive. And if minus T delta S becomes positive, feasibility decreases. You can see in my answer, I talk about delta S, then I talk about T delta S, and then I talk about minus T delta S. And then I base my answer on finally minus T delta S. I hope these ideas are clear to you guys. In the next video, we'll talk about more past papers. Stay tuned, guys. Thanks.